Hi, welcome. In this lecture, we are going to talk about briefly vectors, application of vectors, and resolution of forces. So essentially, vectors need two things. First one is the magnitude, and the other thing is direction. Now a vector is represented something like this. A vector starting at O, ending at A. So for an example, if you have this coordinate system, you have x-axis and you have y-axis, and you have this vector which is OA. As we can see, it is starting at O, ending at A. Assuming this vector makes an angle theta with respect to positive x-axis, it can be observed that we can draw vertical and horizontal lines. So this green line is parallel to y-axis, and say this blue line is parallel to x-axis. Now I want you to observe that this triangle, I'm gonna call this A1, so O, A1 and A. So triangle O, A1 and A is a right angle triangle, which means this angle is 90 degrees. Now let's look at this OA1. Okay, this OA1 is nothing but this OA. If you were to take the cosine of that value, you are gonna get OA1. So this is OA1, which is equal to OA cosine of theta. Now I want you to look at this. Now this is AA1, which is OA sine theta. Now what it means is, this right angle triangle has this hypotenuse OA. It has one side OA1 and A1A, and it can be easily verified that OA square is equal to OA1 square plus A1A square, and this is the Pythagorean theorem that all of us know. Now let's try to understand. This vector OA has the magnitude and the direction. So how do we find out the magnitude of the vector? The magnitude of the vector is found out using this equation. So a magnitude of the vector OA is defined as within two lines. So this stands for magnitude, gives you the magnitude of vector OA. Now it is important to note, magnitude is just a number, and sometimes what we are interested in, we are interested in the direction. So for that we defined something known as unit vector. So unit vector is nothing but it sort of gives us the direction. This vector has magnitude is equal to 1, and it only defines actually the direction in which you want to travel. So let's take an example. Say if I want to go from this point O I want to go to this point A, and there are multiple ways I can go. So let's see, I can travel maybe something like, I can travel this direction. So I can actually stand at O, orient myself in the theta direction, say I turn by theta, say by 45 degrees, and then travel a certain distance. Or what I could do is, I could travel from O to A1, and I could travel from A1 to A. Some of you may say, hey, how about this? Why don't we go from O to B, then turn around in 90 degrees, and then travel from B to A? Either ways is fine. So you can go from O to A, O to A1A, or O to B and A. Now, but interestingly, now if I want to say I want to go from O to A1 and A1 to A, so let me define something interesting here. I'm gonna say this is my unit vector I, and this is my unit vector J. So what does it mean by unit vector I? It means if I travel 1 unit in X direction, I have traveled 1 I. If I travel 2 units in X direction, I have traveled 2 I's. So what it means is, if I have traveled OA cosine theta in X direction, I have essentially traveled OA cosine theta I. So watch out. So this is what's gonna happen. So OA is actually, if you think about it, it comprised of 2 vectors. I need to go from O to A1 and A1 to A. So I would say O to A1 and A1 to A. Oh, by the way, please ignore that email. That was the invitation for drinking beer. I don't drink alcohol, so please ignore that. Anyway, so from next time I would disable the pop-ups. So OA is essentially OA cosine theta I. Now what is A1A? A1A is essentially the travel in the Y or J direction. So if I travel 1 unit in Y direction, I have traveled 1J. If I travel 2 units in Y direction, I have traveled 2Js. So if I were to travel OA sine theta, which means I have traveled OA sine theta J, this is nothing but, as you can see, this is this vector. So this is this vector, this is this vector. Now something interesting to observe here, and this is very important. So observe, I have actually divided this vector into its own components. OA vector is resolved in 2 components, OA1 and A1A. So watch, it is important to note that if I were to combine A1, they get cancelled, and I am left with O and I am left with A1. So beginning of this vector and end of this vector gives me this vector. So unit vector is the vector with magnitude 1. It only indicates the direction. So how do you find the unit vector? So if you have a vector OA, and if you want to find out the unit vector, you just divide the vector by its magnitude. Once you divide the vector by its magnitude, you have this n hat, which is the unit vector which gives you this direction. So let me see. So again, what does it mean? It simply means that if I have this whole vector, which is OA cosine theta I plus OA sine theta j, and I divide this by the magnitude of OA, which is nothing but square root of OA cosine theta square plus OA sine theta square. Now what do I get? Watch, OA comes out of the equation, so OA square, I take the square root, so I get OA. So I have OA. And what do I have in this bracket? So in this bracket I have the square root, and this square root actually is cosine square theta plus sine square theta. This is 1. So I have OA cosine theta I plus OA sine theta j. This quantity is 1. So this quantity is 1. This OA cancels with this, and wow, we have this nice and interesting result that tells me that my unit vector n is simply cosine theta I plus sine theta j. So this is my unit vector. I'm gonna stop here, and in next video I would add some examples.